Hi guys, please look at the screen, and this is come because of the questions that Ainsley was asking, Anastasia was asking. First, how's your assignment? You have only 2 exercises. It's very short. Please listen to me what you have to do. So you have those 2. You have a distributed load, the distance d1, d2, a concentrated load, the distance d1, d2. d2 is bigger than d1, and here you have a square section. Moment of inertia is base, so 60 in the power 4 over 12. And here we have a round section. The moment of inertia is pi d in the power 4 over 64. And after I make a drawing, I make a draw, and these are the numbers. For example, Ainsley was number 6. So what is number 6? This is number 6. The distance d1 is 30, the distance d2 is 90. The distributed load for the first exercise is 15 kilonewtons per meter, and the concentrated load for the second exercise is 12 kilonewtons per meter. So 12 kilonewtons, sorry. So this is 12 kilonewtons. This is 15 kilonewtons per meter. Okay, so this is the distance. Now this is asking in bending. We have 2 kinds of deformation. We have how much goes up or down this section, and we have the rotation. So, and we're going to find with the table method. We're going to find the displacement and the angle of rotation of the point C. So I go to the table. Let's see the table. Where is this one? Let's see, because we have different tables for different. So there are different tables for different Now this is the tricky part. Suppose we have this one, but we have the entire, we have the whole section. So in this case, this is symmetrical. However, you see something, this exercise, that's what I want you to understand the table. The exercise gives how much is the delta here. The theta here should be 0 because it's symmetrical. Now is giving how is the deformation when the distance is x. So that's what you have to apply it when the distance is x for this cross section. Another thing that I'll suggest, what about for this one? What about for this one, for the second exercise? This one, the second exercise, only you see something. So it's just one formula to apply. I'm not asking for the point A. I'm asking for the point A and C. For the point A, you have just to apply directly. The force is given, you see the deltas, is force times L cubical, which is the well for my exercise, is D2, the longer one, over 3, material is given, E, and I is the moment of inertia. And theta the same way. Now, you see this one? This is the deflection equation. What does it mean? When the distance is x. So your x distance, how much is your x distance, guys? Is d2 minus d1. You see this one? This is your x distance. Look at my finger. This is your x. Because here is the origin of the system. So your x is d2 minus d1. What you have to be careful about? Be careful about only the units. Because here the units I've given, you see, in centimeters. And the force is kilonewton. So the units you have to be careful. And you know something? Because the first exercise has more work, don't do it. Just do only the second one. Because for the first exercise are other tables. Just do the second exercise. I just want you to know how to apply the table. How to apply the table. I could not have done the Zoom that Anastasia asked me. You know, guys, I am in this situation. I am in my apartment. I'm not at home because I have my in-laws, old people over there. I don't want them to get sick. And so I'm completely isolated. But here I had 2 laptops and 2 desktops in a whole network. One of the laptop I gave to an international student. He needed, so I gave him to use it. 2 desktop, one crashes. This one has no sound card. So if it is not sound card, here's the camera, but I cannot hear you. You cannot hear me. The other laptop is Apple, and Apple was too old or 6, and Apple does not support many softwares. And you know, I had a backup plan. I had a brand new laptop that Humber gave it to me. Very expensive, $4,000 laptop for me to use it. So I had a backup plan. That one will crash as well. So I am out of resources. I thought I had everything perfect at home. Apparently I don't, because all the time I stay late in Humber, and when I come home, sometimes I see the emails. I live very close from Humber, and that's why I didn't know that I had this situation here. That's why I cannot do it on a FaceTime. But I hope you understand. Once again, this one is easy as well. I can send you the table, but do only this one. Only be careful of the units. Don't be surprised if those values are very small. It's normal to be very small. Thank you. Bye-bye.